Welcome to today's discussion. We are looking at a subtopic in chemistry, Form 1, under the separation of mixtures. This is K.c.s.e 2005, paper 2. When we are talking about mixtures, we know that a mixture is the physical combination of two or more substances in which the substances or the components retain their physical identity. In which the components retain their physical identity. The components that form the mixtures do not change. For example, if you mix maize and beans, then you examine them, you are able to see beans, you are also able to see maize, since the components forming the mixture do not change their physical identity. One of the methods that we use to separate mixtures is what we call chromatography. Chromatography is a method used to separate pigments or colors. There are so many properties that we base on this separation. We will discuss on the properties under chromatography as we move down. Let us look at the question given. The diagram below shows spots of pure substances A, B, and C on a chromatography paper. Spot D is that of a mixture. When we have this paper showing the separated pigments, we call it a chromatogram. Chromatogram is a dry filter paper showing the separated pigments. We have already been told that substances A, B, and C are pure substances, while D is a mixture. After development, A, B, and C were found to have moved 8 centimeters, 3 centimeters, and 6 centimeters respectively. D has separated into 2 spots which had moved 6 and 8 centimeters. Roman 1 on the diagram labeled the baseline. This is the origin or the starting point where we have all the spots, and this is what we call the baseline. And the farthest point that is going to be reached by the solvent, we call it the solvent front. Let us show the positions of the spots. Assuming this is the origin, we give it 0. Then this mark will be 1, 2, 3, 4, 5, 6, 7, and lastly 8. We have been told that A moved 8 centimeters, so A was placed at this origin, then moved along and stopped at that 8 centimeter mark. We are also told that B moved 3 centimeters. B moved 3 centimeters. So 3 centimeters is this point, you can see. Then we have C that moved 6 centimeters. This is our C. We move along this chromatograph paper to where we have 6. You can see 6 at this far end. Then of course we have D, which is a mixture, and D separated into 2 spots which moved 6 centimeters. D moved 6 centimeters just like C, and also moved another spot moved 8 centimeters. So we have one moving 6, another one moving 8 centimeters. That means D, which contains 2 spots, one moved the same distance as C and the other one moved the same distance as A, meaning A and C are the components of D. Let us now go down. We have already answered part 1. On the diagram, label the baseline. We have already done that. This is the baseline, and the farthest point reached by the solvent, we call it the solvent front. Part 2 of Roman 1 show the positions of all the spots after development. We have already done that. Roman 2, identify the substances present in mixture D, and those substances are the same substances which have moved the same distance as these other pure pigments. And we have already seen that C moved the same distance as one of the spots in D, and then of course A has moved again the same distance as one of the spots in D. That means we have substances A and C which are contained in D. The next question we have is part B. Describe how solid ammonium chloride can be separated from a mixture of ammonium chloride and anhydrous calcium chloride. We know that ammonium chloride is one of the substances that sublime, meaning when heated it changes directly from solid to vapor, and when you cool it, it cools from vapor directly to solid. Those substances undergo a process known as sublimation. How do we separate ammonium chloride and calcium chloride mixture? One, we know ammonium chloride sublimes. Ammonium chloride sublimes, whereas but calcium chloride does not. And if ammonium chloride sublimes, then we separate the two using sublimation method. So in this separation, we heat the mixture of ammonium chloride and calcium chloride. Ammonium chloride sublimes, in other words, changes into vapor, sublimes into vapor, and condenses on the cooler parts of the apparatus and condenses on the cooler parts of the apparatus. Another point is that calcium chloride will remain on the bottom of the beaker. Calcium chloride, which does not sublime, remains at the bottom of the beaker, and by so doing the two would have been separated. We go to C. C reads, the table shows liquids that are miscible and those that are immiscible. The first thing we need to understand is that miscible liquids are those liquids that mix uniformly, whereas immiscible liquids are liquids that do not mix, but form layers. An example is water and kerosene, and are immiscible, and examples of liquids which are immiscible, i.e. those that mix uniformly, we have alcohol and water. Use the information given to answer the questions that follow. First, let us analyze this table. We have liquid 1. When mixed with liquid 3, the two are immiscible. Then we have liquid 1 with liquid 4. They are immiscible. But when you mix L2 and L3, they are still immiscible. L2 and L4 are immiscible. The first part of the question reads, name the method that can be used to separate L1 and L2 from the mixture. L1 and L3 are miscible. Miscible liquids are separated using fractional distillation. And it is possible to separate miscible liquids using fractional distillation because they have different but close boiling points. Roman 2 describe how a mixture of L2 and L4 can be separated. Remember, L2 and L4 will be immiscible, and immiscible liquids are separated using a separating funnel. We use a separating funnel. Under this method, since the two liquids are immiscible, we pour L1 and L2 into the separating funnel and allow them to settle. The denser liquid remains at the bottom, whereas the lighter one floats. whereas the lighter one floats. Next, you open the tap and drain the liquid at the bottom. That is the denser one. At the bottom, and leave the lighter liquid in the separating funnel. That is how we separate immiscible liquids, i.e. those liquids that do not mix but instead form layers. Thank you for watching and welcome to this channel. And in case you are watching this for the first time, kindly take 1 second and click the subscribe button so that anytime we produce a video like this, you'll automatically be given a notification. And to the subscribers, thank you so much for continuously supporting this channel through your views and likes.